Hello everyone, we are Team Codexa. We are presenting our solution for problem statement for Smart Safety and Assistance System for Sanitation Workers of Solapur Municipal Corporation. Sanitation workers of Solapur Municipal Corporation perform critical public health duties under extremely hazardous conditions. Every day, they enter manholes and sewer lines, exposed to toxic gases, infections, structural failures, and sudden flooding, all while performing high risk manual operations. Despite their essential role, these operations rely entirely on manual processes with little to no technology support. SMC faces four major challenges. First, no environmental monitoring. There is no system to detect hazardous gases before entry, and workers rely on visual inspection. Second, no worker monitoring or emergency response. Once underground, there is no way to track their health or detect distress, leading to delayed action. Third, no centralized supervision or digital records. Operations are managed through calls with no accountability or data tracking. And finally, scale without support. Managing 102 wards and 8 zones without IoT infrastructure makes real-time supervision nearly impossible. These challenges clearly highlight the urgent need for a technology-driven solution. Our objectives. The first is detecting toxic gases, water rise, and structural risk before entry. The Sentinel Hub classifies the environment as safe or unsafe before any worker descends. The second is monitoring worker vitals in real time. The worker wristband tracks heart rate, SpO2, fall detection, and has a physical SOS button. The third is instant alerts. The alert engine evaluates every sensor reading against threshold and notifies supervisors within seconds. The fourth is preventing unsafe entry. The Start Work button is only enabled when the environment is confirmed safe by the Sentinel Hub. The fifth is centralized tracking and job management. The admin dashboard provides a live worker map, job dispatch, and environmental monitoring across all sites. The sixth is permanent safety logs. Every alert, job event, sensor reading, and vitals is stored permanently. The seventh objective is giving workers visibility into their own health and work history. The worker health dashboard shows each worker their vital trends and past job assignments in one place. On constraints, cost was addressed by using low-cost, widely available components to keep the system affordable for large-scale municipal deployment. Worker usability was handled by keeping the interface simple with minimal controls and regional language support for connectivity. The architecture supports LORA as a fallback for deep underground environments where standard Wi-Fi is unavailable. Maintenance and compliance were addressed through modular hardware and role-based access control on the dashboard. Moving on to our architecture diagram, Layer 1, the Sentinel device. It acts as on-site environment monitoring unit. It detects hazardous gases like H2S, CH4, and oxygen levels along with water rise and structural instability. If any danger is detected, it immediately triggers a local buzzer, strobe alert, and sends an unsafe signal to the system, ensuring safety even if the network fails. Layer 2 is the worker wristband, a wearable device for each worker. It continuously monitors health parameters such as heart rate, SpO2, detect falls or immobility, and includes a panic SOS button with vibration alerts. This ensures we are protecting the worker's health. Layer 3 is the communication module which connects the system. We use BLE and LORA for low power communication and MQTT protocol for cloud transmission. Even in low network areas, local alerts function instantly while data syncs later. Layer 4 is the cloud platform and logic engine, which acts as the brain of the system. It processes incoming data, runs the safe match algorithm to classify safety, performs geofencing verification, trigger alerts, and notification, and stores data for logging and analytics. Layer 5 is the interface level, where the user interacts with the system. Supervisors use a web dashboard for live tracking, safety alerts, and logs, while workers access a gatekeeper app for task updates, health summaries, and safe entry confirmation. The complete flow: sensor reads the environment, transmits over to the cloud, the logic engine processes and evaluates, database stored permanently, and both Garden dashboard and Work Health dashboard update in real time. Together, it creates a complete real-time intelligent safety ecosystem. Let's move on to the prototype walkthrough. This is our physical prototype, the Sentinel Hub. It includes an Arduino Uno ESP32 connected to MQ gas sensor for methane and air quality, an ultrasonic sensor for water level, and all assembled on a breadboard. The sensors are powered and actively reading environmental data in real time. In this live demo, the system continuously reads sensor values. Based on these readings, the microcontroller processes the data and classifies conditions as safe, warning, or danger, enabling real-time monitoring and response. We have also developed a full simulation using Walkvi to validate our system with ESP32, MQ4, MQ135, HCSRO4, MPU6050, OLED display, LEDs, and buzzer. In normal condition, all sensor values are within limits, the system outputs safe and the green indicator is active. When methane's level rise, the system immediately detects it, switches to danger, and trigger alerts. Similarly, poor air quality is detected as toxic air and system flags it as unsafe. When multiple hazards occur together, the system identifies all of them in a single cycle and classifies the situation as danger. This is our admin dashboard showing real-time data from the Sentinel Hub. If any parameter crosses safe limits, the system immediately marks the site as unsafe. This is a key feature, the Gatekeeper app. When the site is unsafe, the Start Work button is automatically disabled and supervisor cannot allow entry. Once the condition returns to safe, the system updates in real time. Only then the Start Work button is enabled. It is a system-enforced safety mechanism that eliminates human error and prevents unsafe entry. Let's talk about why this system is feasible for deployment at SMC scale. The entire hardware setup uses low-cost, widely available components, standard parts available across India, manufacturable and maintainable locally without any specialized suppliers. The software stack is completely open source, no licensing, no vendor lock-in. SMC owns the entire system. The hardware is modular. If a single sensor fails, it is replaced independently without touching the rest of the unit. The dashboard requires no specialized IT infrastructure. Any supervisor with a laptop and internet connection can access it immediately. The impact across 5 dimensions: time and efficiency. The manual inspections and phone-based coordination cause delays. This system automates hazard detection continuously and delivers alert instantly, making operations significantly faster. Cost and scalability. The cost of accidents far exceeds the cost of prevention. Centralized automated monitoring reduces the need for physical supervision at every site and scales across all wards without any infrastructure changes. Worker safety and emergency response. This is the most critical dimension. Hazards detected before entry, not after. The gatekeeper mechanism prevents unsafe entry entirely. If conditions deteriorate while a worker is inside, the supervisor is alerted within seconds. Decision accuracy. Today, the decision to enter a manhole is based on a human judgment under pressure. This system replaces that with a data-driven classification. Every safety decision becomes consistent and reliable. Public impact. Safer workers means more consistent sanitation operations, which directly improves the quality of services delivered to residents and builds public trust in municipal corporation. Finally, what makes this genuinely new? First, the gatekeeper mechanism. Work authorization is enforced by system, not by a person. The start work button is disabled until the Sentinel confirms the safe conditions. Second, a unified real-time pipeline across all 4 interfaces simultaneously. The moment a threshold is breached, the web dashboard, supervisor mobile app, and the worker app all are updated. Third, safe match logic. The alert engine detects multi-sensor correlations. Rising methane combined with falling oxygen triggers higher severity than other reading alone. This enables future integration of AI predictive hazard detection. Sanitation workers risk their lives so we can live safely. Safety shouldn't depend on courage alone. It needs intelligent systems. We are not just building a device, but shifting from risk to protection. Team Codexa believes technology must serve those who serve the society the most. Thank you.